Judges, do you all have the Google sheet with the semifinals rubric that you're filling out? I know Manya is.
Hi, sorry. One of our teammates had a technical difficulty and she's not in the call right now. Could you let her in?
Let me admit her back in.
Thank you.
All right. Whenever you guys are ready, take it away.
Okay. Hi, everyone. My name is Saurav. My teammates Albert, Ria, Ishta, and I are team tech support from the University of Cambridge. Today, we're tackling the Sterlite Power Hackathon Challenge. Next slide. So our solution to the challenge statement is an integrated system to identify, collect, and analyze various behavioral and situational hazards on the worksite. The output of an analysis is certain insights that we can then use to inform our safety-based training, also employing hazard principles. So we'll also touch on why we think our solution is particularly relevant to this kind of scenario. Next slide. So we've identified three major hazards that we've chosen to tackle. These involve risks relating to lack of personal protective equipment, fires, and structural inadequacy.
Whilst doing research for our personal protective equipment detection software, we were not able to find many sources online that included their training data and their trained weights for the neural networks. So we ended up training our own neural network using darknet YOLO model with a training data set that someone else created online specifically for PPE. This included a folder of images and a folder of annotations and text files, giving the type and coordinates of the objects to be detected in the images. The model we ended up using had a weight file that was convoluted over 1,700 epochs, at which point it developed a frame-to-frame average confidence of helmet and vest detection of around 90%. For our fire detection software, we ran OpenCV APIs through Python to apply image processing on video frames. We used the HSV filter primarily to produce masks of potential fires. The bounding values are given here in blue and orange.
We also looked at identifying cracks to look at structural damage, which can obviously lead to many injuries. So for this, we used the concept of transfer learning and we applied it to different surfaces with cracks. So our data set had 30,000 images of surfaces with cracks. And so we trained this over 15 epochs and collected the weights. As you can see the loss values and accuracy. Firstly, the first two columns for the training data and finally for the validation data for each epoch. And so with this analysis, we had an input as a video for a concrete surface cracking. And so we just took the two images before it cracked and after, and as you can see, it does identify it pretty well.
So how are we going to integrate together? So as you can see, we'll monitor the system using the PPE, fire, and crack hazards using the camera network that was mentioned in the previous slides over a period of 1 month or so. And then according to the flowchart, which is shown on the slide here, you can see that after the analysis is done, HAZOP analysis training workshop will be conducted with the workers to let them know and make them aware of what the potential hazards are and what can they do to minimize it and how can they improve their performance, implement any necessary technology, and the information will again be collected over a month and the process will be repeated. Next slide, please. This is the HAZOP training kind of slideshow. The risks are as follows: a not wearing correct PPE, lack of attention, and which can cause potential hazard, fatal injury. What can be done where you need to check that PPE is worn before entering the area, and it can be conducted by the system, the PPE monitoring system, and the task is assigned to the team leader. Fire hazard due to smoking, overheating of equipment, again, fatal injury. Make sure that there is no smoking rule in the factory, CO2 system, detecting system, and the fire detection system mentioned in the previous slide. Cracks in the equipment due to unmaintained equipment, and regular checks need to be done using and you can also use the crack detection software mentioned by my colleague Ria. Next slide, please. So the cost of our system is $30 for the camera and $30 for the smoke detector per unit. Easy to train, open source model. We use Google Colab, or you can use Jupyter Notebook for training, and no computational requirement is needed. Cost efficient and easily scalable. Next slide, please. Next slide. So if you have any questions, do let us know.
So great presentations. Thank you for putting it together. A lot of effort went into it for sure. The question was regarding, I felt that the context here was more of a plant kind of a setup where people are at one location, and therefore you have the systems are set up for having that kind of feedback loop that you articulated, having the workshop, taking it back. When you work in like a linear project, you have like multiple fronts open at the same time, and you typically don't get that kind of a setup where you can bring everyone together, have the workshop. So was that any consideration you thought? I mean, how applicable this would be for a linear project where you have like multiple fronts open at the same time? So it's not a point location where the focus is there.
We did think about that, and so our solution was actually that continuous monitoring will be done by the neural networks over a month, and feedback will be given to a supervisor that doesn't have to be on site, and they can take the necessary action after evaluation.
Anyhow, the team can be divided into sub teams as well, so not all the team need to be in necessarily together at the same time. So if you divide it into a subcategory from the analysis that you get from the video input, the supervisor can divide it into teams, and based on what they're doing wrong, what's the main necessary action to be taken, that'll be the most important part in the heads-up analysis.
Got it. So data capture is basically you equip everyone with the camera, like all the workers are equipped with a camera, and then you record the video for a while, and then you process it once to understand what is going on. Is that the sequence of events here?
It doesn't necessarily have to be one person per camera. It's like one person per group or like an area, and then you can monitor multiple people within that area. So you have a group collection of data and you can have a average of what is actually going wrong. Instead of having it per one person per camera, then it will be a lot of data to generate and actually analyze. So instead, it's just like a group kind of thing.
And especially for the PPE monitoring, we would probably have fixed cameras on site to monitor the flow of people.
And the code itself is quite flexible in terms of what hardware you can use with it. So you can retrofit existing CCTV systems and other systems you have already to just run these models we've developed, and it'll be just as effective.
Yeah, Manya. So I also had the same question, that the focus here was only on the helmet as well as the fire. While in our case, the biggest risk is a person working at 30, 40, 50 meter at height, and there is a chance of he falling from the height.
And we could very easily adapt our code for that, because we have person detection software, and if we give and it gives a coordinate for where that detected person is, and if we have a fixed camera which knows at which coordinate the ground level is, we can very easily raise errors when someone is working at an unsafe height or without protective equipment.
Okay. Right. Thanks.
Thank you.
So from your perspective, what are the limitations of your software? Where do
Um,
you think your software will not work? What are some of the conditions it will not work?
I think the important thing with these machine learning neural networks like such as this is to have a good quality of training data that's representative of the scenario you're trying to analyze. So I think that would be a first initial big challenge, to get representative data of perhaps your work site or like work sites that look very similar to that, and to train our data and a model efficiently. So I think that would be a big challenge initially.
If there aren't any more questions, I think that'll be time. All right, I think that's time. Thank you very much, Team Tech Support.
Thank you.
Thank you.
Thank you.
Right,
Thank
I'm
you for
gonna
listening.